This video assumes that you've already seen the three methods for solving linear systems, graphing, substitution, and elimination, and that at this point you are trying to figure out how to decide which method to use. Because generally what happens is your teacher will give you the three methods, and each day that you're doing those methods, you'll have to do a particular method. And even on a test, they might ask you for a particular method. But usually there's also at least part of a section where you get to pick which method to use. And so for some of us, we would rather just be told what to use. So this might be something that makes us uncomfortable. But there's a pretty easy way for us to be able to decide which choice to use. And here are kind of some guidelines for that. Graphing, if they're already in slope-intercept form, then it would be helpful for us to graph them. So already in y equals mx plus b, especially if they're in y equals mx plus b and there's fractions for the slope, then this would be the way to go, because if we have fractions with y equals mx plus b, then that means that substitution won't be as easy as it otherwise would be. So already in slope-intercept form, I would say for me at least, is the main time that I would look at graphing. But it could be that maybe it's easy to get in y equals mx plus b. So those are our two kind of things that would make us want to graph. And so basically the time that we wouldn't want to graph is if we start trying to solve for y and get a fraction for the y-intercept. So we don't want to graph when the y-intercepts or intercepts are fractions. Slope's fine. We like that slope is a fraction, or we turn slope into a fraction. But if it's if the y-intercept is a fraction, that is not so great. For substitution, if you already have an equation solved for x or y, or if both of them are solved for the same variable, that would be a good time to use substitution. One or both are already solved for a variable. Also, I would say that substitution is something that I would be inclined to use if my numbers, if I tried to do elimination, if my numbers would get really big, then I might do substitution instead. So I don't know that that's really something we need to write down, because it probably won't happen to us in this chapter in Algebra 1, but it's something to think about. Usually what I do is, if the first two methods don't seem like a good idea, my fallback personally is elimination. Elimination is really good because we can almost always find easily least common multiples so that we can eliminate a variable. So LCM stands for least common multiples. So we'd use elimination when it's easy to find the least common multiple to eliminate x or y. So we wouldn't want to do it if we had really big numbers that did not have a good least common multiple. We might see if substitution would be a better way to go, or even graphing might be a better way to go. Something to get both x's to or both y's to. Elimination, typically, I would say, is one of the easier ones to use on any problem, like when we're given the choice. So you might have a different opinion, but that's my thoughts on that matter. So we're going to go through a few examples now and I'll talk through how I decide which way to use. Each of these has a graph on here in case we decide to use the graph, but we may not. So on example 1, our instructions on all of these say choose a method, explain your choice, and then solve the system. So when I look at this, I say, okay, my x's and y's all have numbers in front of them. They all have coefficients. which is another word for the number in front of x or y. And so that means that substitution isn't really a great option necessarily, because we would have to divide by something to solve. So that's probably going to give us fractions. And in fact, I guess we could solve for x in the second one and not get fractions, so it's not impossible to do substitution on this one, but it could be that there's an easier method. The same thing with graphing. These are not in slope-intercept form, so I'd have to do a lot of work to get them into slope-intercept form. So I personally would pick elimination here, and I would do that because I can see that either I can get my x's to have 12s in front, or my y's could have 8s in front, or 16s in front. So that means that I just have to pick a variable to eliminate. So I'll pick y, which means I need to multiply the first equation by a -4. Don't forget that we don't just want them to have the same number, we also want them to be opposite signs. So that's going to give me -12x minus 8y equals -17 times 4 is 68. And so we'll go through and we will add our x's and get -16x. Our y's cancel, and -12 plus -68 is -80. So divide by -16, and that gives me 5. If we weren't sure what that is when we divide, you can always simplify it. Like I could say, well, the negatives cancel, and this could be 40/8, and then when we see it's 40/8, hopefully then we know that it's 5. Once I know what x equals, I'm going to plug it back in. So 3 times 5 plus 2y equals 17. I can plug it into either or any equation. So I picked the first one. But I'm going to subtract 15 and divide by 2 and get 5, 1 for my answer. I actually forgot to name the method I was going to use. I used elimination, or linear combinations is another word for it. So I used elimination because I was able to find a least common multiple for y. Also, a lot of times my personal reasoning for picking elimination would be because the other two methods seemed harder. So that is actually a pretty valid reason. They will seem harder just because of it being more work or them introducing fractions or things like that. Let's look at another example. So on this example, we have one of our equations solved for y. Its y-intercept is all the way up at 11, so my graph is not really super helpful here because it doesn't go up to 11. But then also if I try to solve the first one for y so that I can graph it, I'm going to get a really terrible y-intercept of 13/7. It would be one thing if it was like 3.5 for my y-intercept, but 13/7 is going to be pretty much impossible for us to accurately graph. So I don't want to graph. If I use elimination, I'm going to have to move the -2x over to the left side, and then I can do it pretty easily. But since it's already solved for y, I would just as soon use substitution. So I'm going to use substitution because one equation is solved for y. So that means that I would write 6x plus 7, and then I'm going to write what y equals, which is -2x plus 11, and it equals 13. So I'm going to distribute and get 6x minus 14x plus 77 equals 13. 6x minus 14x is -8x. and I'm going to subtract 77 and get negative 8x equals negative 64. So I divide by negative 8 on both sides. X equals 8. Then I go back and plug back in. The best place to do that is right here where it's already solved for y. You can do it in the other equation. It'll just take you a little longer to solve. I get y equals negative 16 plus 11. So y equals negative 5. So my answer is 8 comma negative 5, which would not have fit on this graph that I provided. So good thing I didn't pick the graph. Example 3. Now they're both solved for y, which means they're in slope-intercept form, and they both have fractions. So if I see this and I'm thinking like, oh, I could use substitution because I can make them equal each other, that's great, but we would have to solve this with those fractions there. And fractions are not bad in themselves. They just make it easier for us to make mistakes. So I'm going to choose graphing because they're in slope-intercept form and because I have a graph handy. If we, for some reason, really wanted to use elimination on this, we actually could, and we even can do it without rearranging things because the y's are lined up and the x's are lined up, but we would have to, I don't know, I think we would have some issues here that we may or may not know how to deal with. Like for one thing, we have to subtract some fractions, and nobody wants to subtract fractions. So if you can graphing actually is a lot of times the least amount of work. I just have to put the y-intercept here at 4, go down 3, right 2. I'm going to do that twice since I have no idea. Whoops, down 3, right 2. So that, because I don't know yet where they'll intersect. So I'm going to ignore that extra dot there. Then negative 1 and down 1, right 4. Which does this like so. So my answer here is their intersection, which is at 4, negative 2. And that's pretty much the gist of what we're doing. And I believe that's the last example. Oh, JK, it's not the last example. So, but that is us doing one of each way. And so really I would say that on this last example that you might think about deciding for yourself and seeing if you can come up with the right answer. This particular one, I would actually say, is pretty easy to do with graphing because I could really easily solve these both for y. It's pretty easy to do for substitution because I could solve for this y right here and then plug into the other one. It's also really easy to do with elimination because I could really easily eliminate x or y here. So pick which method you would like to use. It is helpful at some point to be like, this is the method I am best at. And so when I have a choice, if I don't think I should use a different method, I'm going to always pick this one. For me, that is the elimination method that I fall back on most of the time. But for you, it might be a different method, and that's okay. So see if you can solve this yourself. And I will come up with the answer real quick-ish. I guess I'll have to work it out to do that. If I wanted to graph, I'd have to subtract 3x over on the first one, and on the second one, I'd add 6x over and then divide by 3. So it's y equals 2x plus 6. Well, that's unfortunate that 6 isn't on our graph, but I can pretty easily add it here. 6 and down 2 over 1. This is one line. And then starting at negative 4 and going down 3, right 1, which I don't have room for, so I have to go up 3, left 1. Looks like these intersect here at negative 2, 2. I did that by graphing, and my reasoning for that was I knew it would be easy to solve them for y. But I could technically have done it any of the three ways and still come up with that answer. So if you picked a different method and didn't get negative 2 comma 2, there's got to be a mistake somewhere in there. We should get the same answer using different methods. So see if you can find your mistake. But that is all for this video on how to decide which method to use.